Hello, everyone, and welcome back to another MAT 142 concept session. Today, we're going to be talking about how to find percentages under the normal curve. My name is Nick, and I work at the ASU Tutoring Center, so let's go ahead and get started. Now, before we even tackle this concept, let's go ahead and read our example problem just so we can kind of digest what they're even saying, right? So suppose that the exam scores for a course are normally distributed with a mean of 75 and a standard deviation of 5. What is the minimum score required to be in the top 10% of the scores on the test? Now, first thing that stands out to me is that they say that this is normally distributed, right? So that means we're going to go ahead and just draw our bell curve because we know we're going to need it, right? Next, they say that it has a mean of 75 and a standard deviation of 5. Okay? So what they're looking for here is the minimum score, right? So that means that we're looking for a z value or an x value here, right? Just like that 75. We're looking for an actual exam score that is required to be in the top 10% of the scores. So what they're looking for is the value here that makes this whole area under the curve 10%. Okay? Now, before we look at a z-table real quick, let me just review with you the z-score definition formula, right? So we have z equals x bar minus mu all over standard deviation. Okay? So we know what mu is, right? And we know what standard deviation is, right? So the only two things that we need to figure out is the z and the x bar. And we can actually find this z variable here because this x bar is the equivalent of this x bar here, okay? So what I'm gonna do is go ahead and clear the screen real quick and move on to the next slide. So here, as you can see, is a z table, right? So let's go ahead and just kind of go over just how to digest just some of this information. Now, if you notice, the first thing is that our normal curve looked something like this. If you remember how I shaded it, it was going to the right, right? Whereas up here, it's going to the left. So what we need to do is just realize in our heads that we need to take these large areas underneath the curve and subtract 1 from them. So the area underneath an entire bell curve is equal to 1, right? So if we have 0.0 here, that's why it's half, right? Because we're at that mu point, the mu line, the center line, and just going to the left into a negative infinity. So that obviously makes it 0.5, which means that the whole area under the bell curve is equal to 1. So if we're looking for this area to be equal to 0.1, 10% exactly, what we're really going to be looking for on the table is what z-score is as close as possible to 0.9. Now, if we look around here, we see that we have 0.9066, 0.9049, 32. We have 0.9015 and then 0.8997. So we know that it's somewhere between right here, right? So it's 1.28, and then we'll go ahead and call it 5. So 1.285. Okay? So let's go ahead and remember that, and then we're going to go back a slide, okay? So 1.285. All right, there we go. Let me get my pen back real quick. So we have 1.285. Now this is our z-score, right? So this is our z in our formula that I had written out. So we have 1.285 equal to x bar minus our mu, which we already know is 75, divided by our standard deviation of 5. So from here, what we can do is multiply the 5 over. So we have 1.285 times 5, and we get 6.425. equals x bar minus 75. And then we add the 75 over, which gets us 81.425 as our x bar. And that's our answer. And kind of reflecting on that answer, just to make sure that it makes sense. Well, we know that they want us to be in the top 10% of scores, right? And we know that if you get a 75 on it, you're in the top 55 or the top 50%, right? So the fact that we are about 6 points higher than that 75 tells me that this is a pretty reasonable answer. You know, with a 5 standard deviation compared to something like a 1, these scores are pretty farly distributed, if that makes sense. The bell curve is a lot more flat than it would normally be if the standard deviation was like 1 or 2. So I think this is a pretty fair answer. And this is actually how you solve these kinds of problems. But if you have any other questions, this is a pretty complicated concept. Go ahead and log on to that website on your screen there. On that website, it lists out all of the different free tutoring services at your disposal from being an ASU student. Additionally, if you're looking for just straight up like one-on-one tutoring, you can also enter in the course that you're looking for tutoring for. And from there, it'll actually spit out a list of tutors that you can then go visit around whenever you have time available. But other than that, that's all I have for you today. So I hope you have a great rest of your day and good luck in your course.